Is our existence a mere stroke of luck in the vast cosmic arena? The universe brims with billions of stars, each possibly orbited by its own set of planets. Among these, many are believed to have the perfect concoction for life, teeming with essential elements and residing within the Goldilocks zone of their stars. Yet a perplexing silence echoes through space. Despite the universe's ancient age and our tiny blip in its timeline, we've not received an interstellar RSVP. The staggering numbers suggest a universe buzzing with life, yet the reality seems eerily quiet. The Fermi paradox has puzzled thinkers for years. With such favorable odds, why haven't we heard a peep from our cosmic neighbors? Is it a cause for concern? Strap in, dear viewer, as we dive deep into this enigma and unveil the unsettling answers scientists have stumbled upon while solving the Fermi paradox. Prepare for a journey that might just rattle your cosmic perspective. Chapter 1. Introduction to Fermi Paradox. Let's switch up gears and let me take you on a journey that might just blow your mind. Ever been to a beach and gazed upon the vast stretches of sand? Now, imagine each grain represents a star. Intrigued? Good. Hang tight. Back in 1950, a gentleman named Enrico Fermi, in all his wisdom and not because he forgot his glasses at home, inquired, "Where is everybody?" What he meant was, if the universe is bustling with life, why haven't we been invited for space coffee yet? This mystery is now famously known as the Fermi paradox. Picture this. On a clear night, we only see about 2,500 stars, which is a teeny tiny part of our galaxy. It's like you seeing only the crumbs of a giant cosmic cookie. And remember our sand analogy. If we magnify our understanding, there are about 400 billion stars in our galaxy alone. That means for every grain of sand on Earth, there are approximately 10,000 stars out there. Makes you feel small yet? Now hold on to that beachy thought. If we're conservative and estimate that only 5% of these stars resemble our sun, we're still looking at a mind-boggling 500 billion sun-like stars, the potential for Earth-like planets orbiting them. Roughly 100 billion. I'll let that number sink in. Feeling like a cosmic speck yet? Here's where things get more speculative. If only 1% of these Earth-like planets had life, each grain of sand from your beach vacation would symbolize one living planet. If 1% of these planets had intelligent beings, like us, or maybe smarter, we'd be talking about 10 million billion civilizations in the universe we can observe. That's a whole lot of possible intergalactic neighbors. Diving back into our Milky Way, with a conservative estimate of the number of stars, we might have about 1 billion Earth-like planets. And of these, 100,000 might be home to intelligent life forms. Now here's where it gets really cool. The search for extraterrestrial intelligence, or SETI, with their high-tech tools and satellite dishes, are the cosmic DJs trying to tune into any extraterrestrial radio station. But here's the million-dollar, or maybe interstellar credit question. With the possibility of so many cosmic chatterboxes, why is our cosmic phone not ringing off the hook? Consider our sun. It's like a young adult in the grand spectrum of the universe. Older stars have even older planets, possibly housing civilizations that have seen and learned a lot more than us. If we had to gauge, say, our Earth, with its 4.5 billion years, against an imaginary Planet X that's 8 billion years old, their civilization could potentially be as ahead of us as we are of the medieval knights and damsels. Imagine being amazed by a knight seeing an iPhone. Now, magnify that amazement by, like, a gazillion times. The tech savviness of a civilization merely 1,000 years ahead could feel like magic to us. If they're a million years ahead, our relationship with them might resemble that of humans and chimps. And remember our hypothetical Planet X? They're billions of years ahead. So really, where is everybody? The Fermi paradox isn't just a question. It's a cosmic conundrum that teases our understanding of the universe and our place in it. So next time you're at the beach playing with the sand, remember, each grain could represent a world with stories untold. How's that for a perspective shift? And oh, remember to keep that cosmic phone charged. You never know when the neighbors might call. Chapter 2. How powerful can civilizations get? So ever been on one of those nights where you're looking up, the stars shimmering like diamonds against the black velvet sky, and you wonder, are we the only ones here? And if not, where is everyone? Ah, well, this is what I call the Galactic dilemma. But before we start sending out invites to extraterrestrial tea parties, let's grasp the gravity of our cosmic potential. Ever heard of the term Type 1 civilization? It's like being given a universal remote control to your home planet, and guess what? We're close to getting our hands on it. As humans, we're hovering around a type 0.7 according to the Carl Sand scale. If that sounds like gibberish to you, let me break it down with some relatable context. Imagine every appliance in your home is at your fingertips. That's type 1. Now, envision controlling not just the gadgets in your home, but every device in your entire city. Enter type 2. This would be like us harnessing the power of our very own sun. It's like turning your star into a colossal battery. How? Well, human imagination paints pictures of megastructures like Dyson spheres. But hold on to your hats, because there's type 3. It's like becoming the energy maestro of the entire Milky Way galaxy. Can't picture it? Think about being in charge of every electrical device on Earth. That's the kind of leap we're talking about. It might sound a tad ambitious, but remember our friend Planet X from earlier with an extra 3.4 billion years of innovation? A civilization from Planet X could potentially cruise around galaxies, make pit stops at cosmic cafes, and colonize planets faster than we binge-watch our favorite series. Imagine sending machines to different planets that can copy themselves, and then those copies make more copies, and so on. It's like having a space printer that never runs out of ink or paper. Without even tapping into ludicrous speeds, a civilization could claim the Milky Way in just 3.75 million years. That's like what, a weekend in cosmic time? Now let's indulge a bit. If 1% of all intelligent life can hit that elite Type 3 status, we'd have about, wait for it, 1,000 of these universal moguls in our own galaxy. With such tremendous power, you'd think they'd drop by for a visit, send us a postcard, or at least some cosmic radio waves, right? But here's the billion-star question. If the universe is this grand party with potentially thousands of Type 3 civilizations, why haven't we heard the music? Chapter 3. The Zoo Hypothesis. Have you ever been to a zoo and wondered if you're the one being watched? If that sounds a little eerie, you might want to buckle up for what's to come. Imagine a world where we, humans, are just specimens in a vast cosmic display, a sort of Earth zoo, if you will. The Zoo Hypothesis, an intriguing proposal to the big question, where are all the aliens? Dives deep into this premise. You know when you're watching those cute pandas munching on bamboo, and you make sure not to disturb them? Think of a super advanced alien species doing the same with us, except they're not just outside a glass wall. They could be light years away, ensuring they don't mess up our natural habitat. Sounds a bit out of a sci-fi movie, right? But here's the twist. Some esteemed scientists from places like MIT are taking it pretty seriously. Let me paint a picture for you. Imagine aliens with their sophisticated technology, maybe sipping on their equivalent of a latte, debating whether to like or share a video of Earthlings discovering fire or inventing the wheel. And why might they choose to be silent observers? One argument is that they're avoiding interplanetary contamination. They wouldn't want to interfere with our evolution or societal growth. And for the thrill-seekers among us, there's also the laboratory hypothesis. Picture Earth as a grand experimental setup, and us, well, we're the lab rats. And get this, the assumption is that wherever there's a chance for life to exist and evolve, it will. It's like saying if you put buttered toast and a cat together and drop them, something interesting is bound to happen. Don't try that. It's just a quirky analogy. Given this logic, the universe should be teeming with life. And if there's a galactic code of conduct that most of these extraterrestrial cultures adhere to, it could dictate non-interference with planets like Earth. But here's a quirky thought. What if, in this vast universe filled with countless civilizations, just one rebel civilization decides to break this code? Kind of like that one friend we all have who can't keep a secret. If even one civilization reaches out, the whole zoo hypothesis could crumble like a house of cards. But wait, there's more. Consider a scenario where civilizations throughout the cosmos have strikingly similar norms about interstellar interactions, much like how different species on Earth independently developed eyes. Or perhaps the ancient civilizations, the trailblazers of the galaxy, set a standard that others naturally follow. It's kind of like setting a trend. Once bell-bottom jeans were in, everyone wanted them. Maybe the oldest civilization set a trend of, look, but don't touch, when it comes to emerging civilizations like ours. Now let's sprinkle in some math. Ever heard of Monte Carlo simulations? Well, it's a fancy term for predicting possibilities. Using this, some suggest that the time gaps between the emergence of different civilizations could span eons, comparable to Earth's geological ages. Now ponder this. What could a civilization achieve with a head start of, say, 100 million years or more? Such a civilization could set the rules, norms, and trends, much like how every new human is born into a pre-existing system of traditions and norms here on Earth. So next time you're at a zoo, watching a lion or an exotic bird, pause for a moment and wonder, in the grand tapestry of the universe, are we the spectators or the spectacle? Chapter 4. The Great Filter. Did you ever pause during your daily grind and gaze up, pondering the vastness of the cosmos? What if I told you within this immense universe we might be the equivalent of the new kid on the block? Or, potentially, the only kid? Let's break this down a bit. I bet you've heard about the famous Fermi paradox, essentially asking, if the universe is brimming with stars and possibly life, where is everyone? One gripping theory suggests there's something called the Great Filter. No, it's not the latest Instagram feature. It's much more existential. Imagine the path to becoming a mega-advanced, star-traveling civilization as a cosmic obstacle course. There are certain critical stages life must surpass. For instance, planets need to be just right to support life. On that planet, life has to emerge, evolve from single cells into multicellular organisms, develop technologies, and eventually become capable of space exploration. That's an overly simplified version, but you catch my drift. So what's this about a filter? It's theorized that somewhere along this cosmic obstacle course there's one step so incredibly challenging, so brutally selective, that it prevents almost every form of life from getting through. Ever heard of Robin Hanson? In the 90s, this guy proposed the Great Filter hypothesis. He pointed out various potential milestones in the progression of life, like forming multicellular organisms, evolving to use tools, and developing advanced technology. We, the humans, have ticked many boxes, but are yet to become that spacefaring species colonizing other star systems. But given how ancient the universe is, shouldn't someone else, from another planet, have reached that stage by now? Let's get a bit speculative, shall we? Maybe the universe is filled with simple life forms, but not advanced ones. Picture this: billions of planets with just bacteria. After all, bacteria don't typically launch rockets, do they? Alternatively, maybe every advanced civilization has a knack for self-destruction, be it war, uncontrolled AI, or even catastrophic natural events like asteroid impacts or supernovae. Considering all these, one looming question remains: have we passed the Great Filter, or is it still lurking in our future? If we've surpassed it, hats off. We've aced the cosmic test, and the vast universe might be ours to explore. But on the flip side, if it's ahead, we might have some rough waters to navigate. Some argue that our solitude in space might be a silver lining, suggesting we've successfully crossed the Great Filter. In this vast cosmic story, maybe we're the pioneers. On the contrary, if we stumble upon signals from a way advanced civilization, it might hint that our biggest challenges are yet to come. Intriguing, isn't it? The Great Filter theory, while just a theory, offers a fascinating lens to view our place in the universe. Though it doesn't serve a definitive answer, it surely spices up our quest for understanding. Just a food for thought. If there's a cosmic test awaiting us, how would you prepare? And if we are indeed the first to break through the so-called Great Filter, what responsibility does that place upon our shoulders? Remember, space might be silent, but it always encourages questions. So, what's your take on the Great Filter? Imagine for a moment that you're in a gigantic library, one that holds every possible story of existence. As you browse through this endless collection, you stumble upon a section titled Extraterrestrial Life. The paradox we face, named after physicist Enrico Fermi, questions why, in a universe bustling with chances for intelligent life, we're met with deafening silence. Various theories aim to explain this cosmic conundrum. The Great Filter hypothesis wonders if there's a stage in every civilization's development where they self-destruct, preventing them from becoming advanced. Then there's the rather intriguing zoo hypothesis, likening us to animals in a vast cosmic zoo, watched over by advanced extraterrestrial beings. Perhaps they've chosen to let us be, letting humanity play out its story uninterrupted. These, among other speculations, highlight just how much we're feeling around in the dark, trying to understand why we've not yet had an interstellar meet-cute. But there's more to this pursuit than just science. It's a deep-rooted human desire, isn't it? The hope to one day connect with civilizations that might hold the secrets to questions we've yet to even consider. Imagine the stories they'd share, the lessons they've learned, the histories they've witnessed. This relentless pursuit rekindles our collective imaginations. It's not just about finding life, but also about understanding our place in this universe. Could it be that this quest is lighting the way for something monumental in human history? We hope you enjoyed this video. See you in the next one.